So in the second video, now that we've talked about what a histogram is and some of their shapes, we're actually going to try and create our own histogram. So here it says that we have the data of 60 fifth grade students who were chosen at random to take an IQ test score, or an IQ test, and these are their scores. This is their data. This data for us has already been put from highest to lowest, so our numbers go in order, which is going to make finding how many of them go in each of these classes a little bit easier. So as a reminder, if you're making one from scratch, you would actually have to come up with your own bins. So here I looked and my lowest number was an 81, my highest was a 145, and knowing that I was going from 80, approximately 80 to 150 maybe, I just said the easiest thing to do is kind of groups of 10. And so we did all of the 80s, all of the 90s, all of the 100s, the 110s, etc. And so that's how I was able to create these. Also, notice I made it very careful that it's 80 to 89. Something that I see a lot of students do is they try to make the bins, I'm going to write them here, but they try to make it 80 to 90, 90 to 100. And notice that, sorry, that was my bell. Notice that this can't work because if I actually had the data point 90, I don't know if it goes into this class or this class. And so we have to make it very, very clear which one it goes into. Now, because all of these were whole numbers, I was able to end each of my classes on a whole number. If you're dealing with decimals, that might be where you do 80 to less than 90. So anything that was less than 90 that would go here. And that would include different than what we have here. Anything that would be, like 89.2. That would still fall into this first class. But I went ahead and made these for you guys so we can go ahead and look at putting them here. So now that I have my classes, all I'm going to do is I'm going to take my data and I'm going to figure out how many of them fall into each of these. So first, 80 to 89, those all start with an 8. I have 3 of them. All right, now we can do the next one. Let's do yellow. Doing the 90s, so anything that starts with a 9, there are 4 of those. The yellow is hard to see. I'll make it orange. There we go. All right, so the next one is then anything that is going to be from 100 to 109. So if I get up to 110, I've gone too far. All the way there to 109. Let's see if I have any left. Oh, I do. So now I have to actually take the moment to count how many of these that I had. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's actually going to be 14 of these. So notice I'm just going to keep doing this for each of them. I've already used that color. All right. So anything, if I've gone up to 120, I've gone too far. So I have 3 of them here. I have a lot. So I already had 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so now if I've gone up to 130, I've gone too far. All right, so I have 2 of them there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Getting close to the end of my data. Let's see how many I have in the 30s. Got a decent bit there. There's maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. And then last but not least, I can see that I have 2 in the 40s. So notice all I did was I actually split my data up, and I used color coding here, but I split my data up into these different classes and I counted how many of them actually exist in each of these. Now I can come over and I can make my histogram. On the x-axis is going to be numbers that relate to my data. So I need to go from 80 to 149 or 150 on my data. So I'm going to start here at 80. I'm going to try and make all of these fit. 80 to 90 to 100, 110, 120, 130, 140, and 150. Now, one of the things I didn't do, because I'm just sketching this out, I didn't make sure each of these were perfectly the same, but I estimated to try and make sure that the distance between each of these are approximately the same. Because this is a graph, this would be an x-axis, and so we know that it would take the same distance to go from 80 to 90 as it does from 90 to 100. So we're actually counting up here, and then we're saying how much data falls in these areas. So my lowest one at 0, obviously, so I could do 5, 10, 15, 20. I don't think I had any above 20. Um, and you can also find your extra, you could take it off more to be more precise here. For the sake of this, I'm just going to do my best to estimate. And now I'm going to actually go and put these in. So I'm going to start, my first bin was 3. So if that's half, that's 2.5. So I'm going to go slightly above that. All right. I zoom out really quickly. My next one is 4. So it needs to be ever so slightly taller than this, but not up to 5 yet. Okay. 100 to 110 is 14. So I'm going to go I'm going to kind of help me out here because I don't have a ruler on here. I'm going to sketch out, and I'm going right beneath the 15 mark, so I know that that's going to be close. So I'm going to go up to this and over, and this may be slightly too long. I can erase that one now. So I did up to 14. The next one is 17. So I'm going to do a similar thing here. I know that between 15 and 20, 17 is ever so slightly less than that halfway mark. So I'm going to draw a horizontal line over so that you have kind of an idea where I'm going. Once again, if you had a ruler, you could just go straight up to that. So I'm going to bring this up to the 17, mark it over. My next bin from 120 to 129 is 11. So 11 is just ever so slightly above 10. So once again, I'm going to kind of give myself a guide bar here. If you had a ruler, once again, that's what you would do. Then bring this side up to that line, draw it over, erase my guideline. The next one is 9. So 9 is not going to be that much further down, but it's going to be the other side of 10. And last but not least, my last one is 2, which is smaller than all of my first ones. So I'm going to kind of give myself a sketch. It's going to be less than this halfway line. Alrighty. And I erase that guideline. Oops. Okay, erase that guideline. Here we have it. We've created our histogram of the data. So that is how we create a histogram by hand. I'll be honest, a lot of technology will create histograms for you, but doing the practice of doing it by hand is really important to get a better idea of what you're actually doing. The last thing that I would do that I haven't done yet is always make sure you're labeling your axes. No graph is perfect unless you have an axis or both of your axes labeled. So this one, like we said, our y is always going to be our frequency. So this, remember, says how many data points fell into each of these classes. And then once again, our x-axis is what we are actually collecting. So this represents the IQ scores of 5th graders because that's what our data represented. So we can have this. The last little bit of what we could do is we could go ahead and draw a density curve over this. So starting kind of making sure you're coming up to hit those peaks and then coming back down. Looking at this one, you can see it's not perfectly symmetrical, but this is pretty symmetrical. I would say that this data, just looking at the density curve, would be approximately normal. In order to figure out if it really is or not, I could figure out how much data falls within, one standard deviation away from the mean, as we've looked at before. But just looking at the basic shape, I would say it is approximately symmetrical, approximately normal. Not perfectly, but approximately.